So this is a statement of addition theorem. As I said to you that addition theorem involves union. Probability of A1 union A2 union so on An is equal to union I is equal to 1 to n. P of Ai is equal to means the same as you have n number of unions here. You can write that as union I is equal to 1 to n. P of Ai is equal to sigma P of Ai minus double summation P of Ai intersection Aj plus so on minus 1 whole power n P of A1 intersection A2 intersection An. This is a statement we need to prove. As I said you should learn the statement also. To prove this, as we have n number of events here, we are going to use mathematical induction. Under mathematical induction, what are the steps we are going to follow? We are going to consider this as statement number 1. Okay, we prove the statement is true at n is equal to 2. Some of you asked that can we start with 1. Here we should start with minimum of 2. So we prove that the statement is true at n is equal to 2. The second case, we assume that it is true at n is equal to some value r or k. We assume and we prove that it is true at n is equal to r plus 1. So prove at n is equal to true, assume at n is equal to r, and we prove it is true at n is equal to r plus 1. So why I am repeating this again and again? We addition theorem, Boole's inequality, multiplication theorem. These three theorems, while proving these three theorems, we are going to use the same mathematical induction. What are the three theorems? Addition theorem, multiplication theorem, and Boole's inequality. While doing these three, we are going to use mathematical induction. So always the same one. Consider the given statement as 1. So this is equation number 1. So we prove this by mathematical induction. Mathematical induction. What is the first step? That is, we prove 1 is true at n is equal to 2. We are going to prove this is true at n is equal to 2. That is, when you put n is equal to 2, I hope you will get only 2 terms. That is, here you have n. If you put n is equal to 2, only 2 you are going to get, which is equal to sigma I is equal to 1 to 2 P of Ai minus, okay, double summation. Here also you will get P of Ai intersection Aj. Okay, only you will get 2 terms here. As we are putting, you won't get this term. Even though if you put n is equal to 2 here, you will get minus 1 whole power 2 minus 1 P of 2 minus 1 is 1. So minus 1 P of A1 intersection A2. So when you put n is equal to 2, equation 1 changes into this form. So this is nothing but P of A1 intersection A2 is equal to, as you have sigma here, first put I is equal to 1. You will get P of A1, P of A2 minus double summation P of Ai intersection Aj. So you won't get sigma here as you have only 2 terms. So this is the term which you need to prove. To prove this, still you need to prove this statement. For proving this, okay, consider this Venn diagram. As we have done in the previous theorem. This is A1, A2. I think this part represents A1 intersection A2. This part intersection not A1 but A2. This stands for, I think this one already we have discussed, so I am not again repeating this. I think this consists of 3 parts. A1 intersection A2 bar, A1 intersection A2, A1 not A1 and A2. Now, if I want A1 union A2, what do you mean by A1 union A2? The entire part is called, this is A1 intersection A2, A1 intersection not A2, A1 not intersection A2. If I want A1 union A2, the entire together A1 A2 called A1 union A2. So can I write this as A1, okay, this circle, I can write this circle and this part, A1 union A1 intersection A2. Okay, I can write A1 union A2 as this first circle and this part. What does this part stands for? A1 bar intersection A2. So I wrote P of A1 A2 as P of A1 union A1 intersection A2 bar. Okay, if I take probability on both sides, I will get P of A1 union A2 is equal to P of A1 union A1 intersection A2. So using axiom 3, as A1 comma A1 intersection A2 are mutually exclusive, I can write P of A1 union A2 as, using axiom 3, P of A1 union of the probabilities is nothing but sum of the probabilities, this one. Okay, this is P of A1. I think we did another theorem where P of A bar intersection B, as I said, the one without bar you are going to get in first, P of B minus P of A intersection B. We did theorem number 1. I think just in the previous class we have did that. P of A bar intersection B as, you will get without bar P of B minus P of A intersection B. Here you don't have bar for A2, you will get P of A2 minus P of A1 intersection A2. So you got P of A1 union A2 is equal to P of A1 plus P of A2 minus P of A1 intersection A2. I think if you consider this as equation number 2, okay, I think you got, by considering the LHS of equation number 2, you got the RHS of equation number 2. So we have proved that 1 is 2 at n is equal to 2. So we can say that equation given statement is 2 at n is equal to 2. What is the next step in mathematical induction? You need to consider, you need to assume that 1 is 2 at n is equal to r. Let us assume that n is true, equation number 1 is true at n is equal to some value r. Means we assume that it is true at n is equal to r. So put n is equal to r in the given statement. A1 union A2 union AR, which is equal to P of union I is equal to 1. I am just replacing this in equation number 1. R in equation number 1. I think this is the statement which we will get. AR. So let us take this as equation number 3. The same order, better you consider given statement as 1. It is 2 at n is equal to 2 as equation number 2. Assuming it is 2 at n is equal to r as equation number 3. So what is the next step? You need to prove 1 is true at n is equal to next one r plus 1. If you can prove this statement, we can say that 1 is proved or 1 is true for all the positive integral values of n. So then if you put n is equals to r plus 1 in given statement, then you will get P union I is equal to 1 to r plus 1, AI is equal to sigma I is equal to 1 to r plus 1, P of AI minus double summation P of AI intersection AJ plus so on plus minus 1. Here if you have n minus 1 there, if you put r plus 1 that, you will get this. You go back to the statement 1 here. If you put here n is equal to r plus 1, you will get P of A1 union I is equal to 1 to r plus 1, P of AI is equal to I is equal to 1 to r plus 1, P of AI minus P of AI intersection AJ minus 1 whole power n minus 1 means you will get r plus 1 minus 1. P of A1 intersection A2 intersection AN, you'll get AR plus. You need to prove this. To prove this, I am going to consider the LHS of this equation, which is nothing but this statement I have considered. So the same step, you remember that I am going to have 1 to r plus 1 means you have how many terms? You have 1 to r plus 1. Means what is the term before r plus 1? This is rth term. So if I write 1 to term, it means that if I write the numbers from 1 to 10, it is clear that I have the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So similarly, if r plus 1 is the last term, what is the term previous to this? Rth term. So I am splitting entire r terms to two parts, 1 to r, and this has the one part, this has the second part. So I am going to write probability of union I is equal to 1 to r AI. This is the important step here. Can I write this in this way? This is the LHS of this equation. Union I is equal to 1 to r plus 1 AI. This 1 to r plus 1 is splitted into two parts, 1 to r and r plus 1. So I wrote that as union I is equal to 1 to r AI union AR. So if I take this as A1 and this as A2, it is in the form of P of A1 union A2. We know that this statement P of A1 union A2 is equal to P of A1 plus P of A2 minus P of A1 intersection A2. P of A1 union A2 is P of A1 plus P of A2 minus P of A1 intersection A2. So it is also in the same form where in place of A1 we have union I is equal to 1 to r AI. In place of A2 we have AR plus 1. So we have union I is equal to 1 to r plus 1, AI is equal to P of A1 union A2 is P of A1 plus P of A2 minus P of A1 intersection A2. This is P of A1 plus P of A2 minus P of A1 intersection A2. Can I write it this way? As in place of A1 you have union I is equal to 1 to r AI, union I is and in place of A2 you have P of AR plus 1 minus union I is equal to 1 to r AI intersection AR plus 1. So what is union I is equal to 1 to r AI? We have assumed that it is 2 at L is equal to r. So union I is equal to r is, we can replace the RHS of equation number 3. So we can write here this can be replaced with RHS of equation number 3. What is RHS of equation number 3? Sigma I is equal to 1 to r P of AI minus double summation P of AI intersection AJ plus so on minus 1 whole power r minus 1 P of A1 intersection so on AR. This one is the first term here is same as LHS of equation number 3. So you consider the LHS as the LHS are equal. This term can be replaced with RHS of equation number 3, which is nothing but this plus P of AR plus 1 minus P of union I is equal to 1 to r AI intersection AR plus 1. So I think these two terms can be combined. You have P of I is equal to 1 to r AR plus 1. So we can raise the sum here. I is equal to 1 to r plus 1 P of AI. Okay, you have P of AI up to r. You have, as you are adding P of AR plus 1, we can write that as I is equal to 1 to r plus 1 P of AI and minus write the remaining terms as it is. Okay, so again so we got this as sigma I. So you got the, I think first term is tallied with the RHS. So if you go here to the next terms, let us write the first terms as it is. Let us look at the last term. Union I is equal to 1 to R, AI intersection AR plus 1. If you go back to the equation number 3, what is equation number 3? Union I is equal to 1 to R. Union I is equal to 1 to R. This is equation. Union I is equal to 1 to R. AI is equal to this part. So if you observe this part, you have union I is equal to 1 to R. In place of AI, you have AI intersection AR plus 1. Again, we can consider equation number 3, RHS of equation number 3 to expand this term. So how much you will get if you expand this term? In place of AI, you have AI intersection AJ. So here you will get this term as minus summation P of AI intersection AR plus 1 plus so on minus 1 whole power R minus 1 P of A1 intersection so on AR plus 1. So you got this as sigma I is equal to 1 to R plus 1 P of AI. So these two terms are same, but in place of J you have R plus 1. So we can write that as 1 to R plus 1 P of AI intersection AJ. From these two terms you have minus 1 whole power R minus 1 as common. If you take out that as the common one, how much you will get here? This term is P of A1 intersection so on AR plus P of A1 intersection so on AR plus 1. So which probability you are going to get if I write these two, A1 intersection so on AR, A1 intersection A2 intersection AR plus 1. If you observe these two probabilities, I think this probability is more when compared to this. So you will get this term as sigma I is equal to 1 to R plus 1. See here you have minus. So you have minus here in front of all the terms. So if you take out plus minus 1 whole power R minus 1, you will have get P of A1 intersection A2 so on. As you have minus here, you will get minus P of A1 intersection A2 intersection AR plus 1. So P of AI I think here you have probabilities up to AR and AR minus 1. From these two terms we observe that this probability is more than this one. So you will get as like if you add minus 2x plus x, how much you will get? Minus x. As you have these two among these two terms, this term is the biggest term. So you will get minus of P of A1 intersection so on AR plus 1. Okay, so you will get this as minus. You have I'll write this down again. You have considered a P of union I is equal to 1 to R plus 1 AI. For that you got sigma I is equal to 1 to R plus 1 P of AI. And here you got minus 1 whole power R minus 1 into minus 1 P of A1 intersection so on AR plus 1. So this is sigma P of AI minus double summation P of AI intersection AJ. As the bases are equal, you can add the powers R of minus 1 plus 1. I think this is nothing but RHS of equation number 3. I think it's a very lengthy one and also confusing one. So this is nothing but this is the RHS of equation number 4, where you need to prove the given statement as equation number 4. Sigma I is equal to 1 to R plus 1 P of AI. You got this one. Double summation P of AIJ. Here you got minus 1 whole power R plus 1 minus 1. Here also you will get R plus 1 minus 1 A1 intersection A2 intersection AR. So 1 is true at n is equal to r plus 1. So my mathematical induction, the given statement is true at all the given statement is true for all positive integral values of n. Hence proved. So better you go through this theorem twice, unless that you cannot understand. It's a lengthy one, and also we are going to make use of equation number 3 again and again. Please go through it. Okay, thank you.